Okay, so like I mentioned in the announcements, we're at the point in the semester where we're providing a little bit of a smorgasbord of different ideas, a little taste. So we're not going to go into parametric equations a lot. We're just going to do a little bit here in this one section. You'll get more work with that if you go on and take more math classes. Okay, so say you have, the Earth is revolving around the sun and the moon is revolving around the Earth. Well, maybe you want to know something about the distance, or something. But it's related to time. But two different things are going on. The moon's going around the Earth and the Earth's going around the sun. Okay, so when we talk about a parameter, we're going to bring in another variable that relates to both x and y. So related to x and y. Okay, so let's say you have this equation over here. We've seen that equation before. That's the equation of a circle with some radius r. Okay? Now, you could solve for r, but I'm not going to. I'm going to solve for y. So I would have y equals plus or minus the square root of r squared minus x squared. Okay? Now, that still is not a function, so you may have learned that in other classes. Oh, if you want to know if it's a function, solve for y, and if you always only get one solution, then it's a function. But here you don't because of the plus or minus, so still not a function. However, we could split it up. We could say, well, let's have one equation that does just the positive part, and another equation that does just the negative part. Well, now, each of these, this is a function, and this is a function. Okay, so kind of what we want to do, thinking along those lines. Okay, so now we'll get to the parametric equations. So we're going to have ordered pairs. They're going to be some function in some t. And t is going to represent time for us. It's just the new variable, okay? And then we have some y that's going to be a function of t as well, okay? Now, the equations that you get, x is going to be equal to some function of time, and y is going to be equal to some function of time. These are the parametric equations. Okay, so we'll give you an example. This one's not super exciting, but we'll talk about it a little bit here. I'm going to make that a little bit bigger. Okay. We have, it says parameterize the curve y equals x squared minus 1. Now we know what that looks like. It's a parabola, it's shifted down 1. We know all about that curve. But then it says letting x of t equal t. So it gives us a function for x, okay? So what we're going to do is we're going to replace this t in for x. So we get y equals t squared minus 1. Now, that might not be very exciting, but, we have that. In the world of ordered pairs, then, we're going to be putting in a t, and then we're going to be finding y of t. Okay? So, we can think about putting in a bunch of values, but let's just make a table of values here where we're going to say t, and we can say x of t, I guess, just to be more accurate. I mean, I could write this x of t, I want the parenthesis, because it's not always just going to be t, that's the thing. Okay, but in this case it's t. So, and then you're going to have y of t. Okay, so let's just do -2, -1, 0, 1, and 2 for t. And then x of t is actually going to be the same thing in this case. It's not always going to be, but it is in this case. That's why I said this one's not very exciting. And then we can think about, well, what would the outputs be? So plug in t here, and you're going to get 3 and 0, and -1, and 0, and 3. Okay? Now we can plot those. So -2, 3, and -1, 0, and 0, -1. And we get this parabola just like we were expecting to get this parabola. And so you might be saying, well, that's not very exciting. It doesn't seem to really change anything. But what we want to think about is t being time and what's happening. Well, as the time is increasing, our parabola is decreasing, right? Our function is decreasing. And then it gets to when t is 0, and then it starts to increase. So it's kind of like you want to consider that path and what's occurring over t. Okay, so that's just a brief introduction.